naming Diyos. Maraming salamat po sa buhay at lakas na aming Bignay, sa liwanag ng kaisipan at sa pagkakataon maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Great morning, grade 11 students, parents and teachers. Welcome to another learning session in Statistics and Probability. I am Mr. Jherald Gabica and I will be your live stream teacher for today. Now, we're going to discuss the lesson for week 2 of quarter 3 entitled Computing the Mean and Variance of a Discrete Probability Distribution. Please get all your learning materials, modules, pen and notebook, as well as your calculators. Before we start with our discussion, let's take a look at our learning objectives. At the end of the lesson, you should be able to compute probabilities corresponding to a given random variable, illustrate the mean and variance of a discrete random variable, and calculate the mean and variance of a discrete random variable. Are you ready? Great! First, let's now have a quick recap of our previous lesson. All you need to do is to choose the letter of the correct answer. Key in the letter of your choice in our comment section. You have 5 seconds to answer. Number 1. What is the numerical description of the outcome of a statistical experiment? A. Numerical coefficient. B. Literal coefficient. C. Random variable. Or D. Dependent variable. 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The correct answer is C. Let's have the second item. What is the random variable obtained from a counting process? A. Discrete random variable. B. Continuous random variable. C. Dependent random variable. Or D. Independent random variable. 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The correct answer is A. Let's see how we make it to the third item. It is a table that gives a list of probability values along with their associated value in the range of a discrete random variable. Is it A. Continuous probability distribution, B. Discrete probability distribution, C. Dependent probability distribution, or D. Independent probability distribution? 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The correct answer is B. And for our last item, number 4, what is the sum of all the individual probabilities in discrete probability distribution? Is it A. Less than 1, B. Greater than 1, C. Equal to 1, or D. Greater than 2? 5 seconds. Go.
5, 4, 3, 2, 1.
The correct answer is C. How was your score? If you got 4, then it seems you've learned a lot with our week 1 lesson. Up for some more? Our next activity is called 555 drill. 555 stands for 5 items, 5 points in 5 seconds. Given the values for each item, all you need to do is solve for the unknown. You may use your calculator and comment your answer in our comment section. Ready? Let's begin. Number 1, given x sub 1 is equal to 4, x sub 2 is equal to 2, x sub 3 is equal to 5, and x sub 4 is equal to 1, find summation of x. Remember that uppercase sigma means summation or sum of x values. You have 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. Let's have the solution. Summation of x equals to x sub 1 plus x sub 2 plus x sub 3 plus x sub 4. That is 4 plus 2 plus 5 plus 1. So the correct answer is 12. Number 2, using the same given, find the summation of x over n. The summation of x over n is simply the average of x values. You have 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The solution is x sub 1 plus x sub 2 plus x sub 3 plus x sub 4. That is 4 plus 2 plus 5 plus 1 is equal to 12. Divided by the number of item values, which is 4. So 12 divided by 4 is equal to 3. Next, we have the given y sub 1 is equal to 2, y sub 2 is equal to 1, y sub 3 is equal to 0, and y sub 4 is equal to 2. Find summation of y. 5 seconds. Go.
5, 4, 3, 2, 1.
Our solution is summation of y is equal to y sub 1 plus y sub 2 plus y sub 3 plus y sub 4. That is 2 plus 1 plus 0 plus 2 is equal to 5. Number 4, using the same given, find summation of y over n. 5 seconds. Go.
5, 4, 3, 2, 1.
Our solution would be 2 plus 1 plus 0 plus 2 is equal to 5. Divided by the number of item values, which is 4. So 5 divided by 4 is equal to 1.25. Our last item, given the table of values, you need to solve for summation of x times y. 5 seconds. Go.
5, 4, 3, 2, 1.
For the solution, we multiply x and y values respectively. 4 times 2 is 8, 2 times 1 is 2, 5 times 0 is 0, and 1 times 2 is 2. Getting their summation, 8 plus 2 plus 0 plus 2 equals 12. How was your score? If you got it all, that's impressive. The items we have a while ago are all connected with our lesson today. Let us have the first example on how to construct probability distribution table and how to compute for their corresponding probabilities. Considering this table of scores of 50 students in a test, the scores of 50 students in a test is shown in the table. We need to construct a probability distribution table and determine the following probabilities. Letter A, the probability that x random variable is equal to 43. Letter B, the probability that the random variable x is less than or equal to 35. And letter C, the probability that x is greater than 25 but less than 43. First, we need to construct a probability distribution table. To do this, we need to solve for the individual probabilities P of x for each test score x. For the first P of x, out of 50 students, 4 students got 50. That is 4 over 50 or 0.08 in decimal. For score of 43, 12 students out of 50 got it. So 12 over 50 or 0.24. For score of 35, there are 15 students. So 15 over 50 or 0.3. For score of 25, there are 10 students. So 10 over 50 or 0.2. And lastly, for score of 24, there are 9 students. So 9 over 50 or 0.18. Always remember that the sum of individual probabilities of discrete probability distribution is 1. And that's it. This is our probability distribution table. Next thing to do is to solve for the following. Determine the probabilities of the following. For letter A, the probability that the random variable x is equal to 43. To solve for letter A, using our probability distribution table, just look for the probability of x, which is equal to 43. And that's probability of x is equal to 0.24. For letter B, or the probability that the random variable x is less than or equal to 35, using our probability distribution table, we just look for the probability of x which are less than or equal to 35. And those are the probabilities of P of 24, P of 25, and P of 35. So, the probability that the random variable x is less than or equal to 35 is equal to P of 24 plus P of 25 plus P of 35, that is 0.18 plus 0.2 plus 0.3. So the probability of the random variable x that is less than or equal to 35 is equal to 0.68. Lastly, to solve for letter C, or the probability that x is greater than 25 but less than 43, we just look for the probability of the scores which are between the score of 25 and 43. And that's the probability of 35. So, the probability that x is greater than 25 but less than 43 is equal to the probability of 35 or equal to 0.3. Moving on, let's have the definition and formula of mean and variance of a discrete probability distribution. For the mean of a discrete probability distribution, the mean, or using mu symbol, of a discrete random variable is the central value or average of its corresponding probability mass function. It is computed using the formula mean is equal to summation of x times the probability of random variable x. And for the variance of a discrete probability distribution is given by the formula variance is equal to summation of the quantity of x minus mean squared times the probability of the random variable x. Let's now proceed with the definition of the mean of a discrete random variable. The mean of a discrete random variable can be regarded as a measure of central location of a random variable. It is the weighted average of the values that x can take, with weights provided by the probability distribution. It is also sometimes called the expected value or expectation of x, denoted by E of x. And for the variance of a discrete random variable, it shows the variability or the scatterings of the random variables. It also shows the distance of a random variable from its mean. Since we already know the definitions of mean and variance, let's now have this sample problem. Reminder, as we discussed, you can comment your answers in our succeeding solutions. Here's our first example. Example 1. Calculate the mean and variance for a random variable x defined as the number of tails in 2 tosses of a coin. We already had this experiment in our last week's lesson. The illustration of 2 coins are tossed is shown below. And the table for possible outcomes and value of the random variable is the possible outcomes, h and h. The value of the random variable x, or the number of tails, is 0. For h and t, the value of the random variable x, or the number of tails, is 1. For t and h, the value of random variable x, or the number of tails, is 1. And for t and t, the number of tails is 2. Using the table we have a while ago, we can produce a probability distribution table using x is equal to 0, 1, 2, and sample space HH, HT, TNH, and TNT. So, the table looks like this. So, the x values are 0, 1, and 2. The frequency for 0 is 1. The probability of x is 1 over 4, since there are 4 possible outcomes. and then the probability is 0.95. For x that is equal to 1, our frequency is 2, or 2 over 4, or 0.5 in fraction. For x that is equal to 2, we have 1, and that's 1 over 4, or 0.25. So the frequency is equal to 4. To solve for the mean, we follow these steps. First, construct probability distribution table. Second is to multiply x and the probability of x. And third is to sum up the product of x and the probability of x. For our first step, we can now use the table we solved a while ago. So we just remove the frequency column, so that is x is 0, 1, and 2. The probability of x is 0.25, 0.5, and 0.25 respectively. For step 2, we simply add another column for the product of x and p of x. So our table looks like this. So 0 times 0.25, the probability of x, or the product of x and px is 0. For x that is equal to 1, times the probability of p of x 0.5, that is equal to 0.5. And for x that is 2, times the probability of 0.25, that is equal to 0.5. For step number 3, we just sum up the product of x and the probability of x. So that is mean is equal to 0 plus 0.5 plus 0.5. So our mean is equal to 1. Next, to solve for the variance, we follow these steps. Step 1, we compute the mean value of the random variable. Step 2, we subtract the mean from each value of the random variable x and square the differences. Step 3, we multiply the squared differences by the corresponding probabilities. And step 4, we add all the products. From our previous example, our mean is equal to 1. So what we will do to have our second step is to subtract the value of random variable x and mean. So for our x, that is equal to 0, so that is 0 minus 1 equal to negative 1. Next is 1 minus our mean 1, that is equal to 0. And then for x that is 2, 2 minus 1 is equal to 1. Next is we square their differences. For negative 1 squared, that is equal to 1. For 0 squared, that is 0. And 1 squared, that is equal to 1. For step number 3, we multiply the squared differences by the corresponding probabilities. So we will add another column. So for our first, 1 times 0.25, that is equal to 0.25. 0 times 0.5, that is equal to 0. And 1 times 0.25, that is equal to 0.25. For the last step, we simply add all the products. So that is the summation of the quantity x minus mean squared times the probability of x. So 0.25 plus 0 plus 0.25 is equal to 0.5. And that is our variance. Using the same example in number 1, here are the steps in computing the variance. So the alternative solution in computing the variance are, so let's have our steps. For step number 1, we need to compute the mean value of the random variable. So a while ago, we have solved the value of the mean, and our mean is equal to 1. For the second step, we need to multiply the square of the value of the random variable x by its corresponding probability. So we will make a 3-column table with x, p of x, and x squared times p of x as its column. So our first row is 0 times 0.25. So the product is 0 squared times 0.25 is equal to 0. Next is 1 times 0.5. So 1 squared is 1 times 0.5. That is equal to 0.5. And we have 2 times 0.25. So 2 squared times 0.25 is equal to 1. And then the third step is to get the sum of the results in step 2. So we have the summation of x squared times p of x is equal to 0 plus 0.5 plus 1. So that is equal to 1.5. And our last step is to subtract the square of the mean from the results obtained in step 3 to get the variance. So variance is equal to summation of x squared times p of x minus mean squared. So the variance is equal to 1.5 minus 1 squared. That is 1.5 minus 1. So our variance is 0.5. So using the alternative solution, we solve for the variance, the same as our first example. For our second example, a survey conducted by our researchers showed the number of student siblings of grade 11 Albert Bandura Gas in Bignay National High School, Senior High School. So the table that we have is the number of siblings 1, 2, 3, and 4, and the probability or P of B of 0.09, 0.36, 0.43, and 0.12 respectively. Now to solve for the mean, we just need to multiply the value of V and its corresponding probability. For the value of 1 times 0.09 plus the value of 2 times 0.36 plus the value of 3 times 0.43 plus the value of 4 times 0.12. So that is 0.09 plus 0.72 plus 1.29 plus 0.48. So our mean is equal to 2.58. To solve for the variance using the alternative solution, we will use the steps to compute the variance. So our first step is to compute the mean value of the random variable. Second is to multiply the square of the value of the random variable v by its corresponding probability. Third, get the sum of the result in step 2. And step 4 is to subtract the square of the mean from the results obtained in step 3 to get the variance. So for step number 1, we compute the mean value of the random variable. A while ago, our mean value is equal to 2.58. For the second step, we multiply the square of the value of the random variable v by its corresponding probability. So using the same table, we will just add another column for v squared times p of v. So for v value of 1, we'll just have 1 squared times the probability of 0.09, that is equal to 0.09. For the random variable b, that is 2, we have 2 squared times 0.36 equal to 1.44. For random variable value of 3, we have 3 squared times 0.43, and that is 3.87. And for random variable v, that is 4, we have 4 squared times 0.12, that is equal to 1.92. For the third step, we just get the sum of the results in step number 2. We just have the summation v squared times p of v. That is 0.09 plus 1.44 plus 3.87 plus 1.92. So the summation v squared times p of v is equal to 7.32. For the last step, we will just subtract the square of the mean from the results obtained in step 3 to get the variance. Our formula is variance is equal to summation of v squared times p of v minus mean squared. So
So from step 3, the summation of v squared times p of v is equal to 7.32 minus our mean in step 1, so 2.58 squared, and that is 6.6564. So 7.32 minus 6.6564 is equal to 0.66, and that is our variance.
Now, let's apply what you've learned in our lesson today. The probability distribution below shows the number of hours y spent by students using mobile phones in a day. In the table, for the value of random variable y equal to 6, the probability is 0.14. For the value of random variable 8, the probability is 0.52. And for the random variable y equal to 10, the probability is 0.30. Time's up. The solution would be mean is equal to summation of y times the probability of the random variable y. That is 6 times 0.14 plus 8 times 0.52 plus 10 times 0.34. That is 0.84 plus 4.16 plus 3.4. So our mean is equal to 8.4. Now, using the same given, you have 40 seconds to compute for the variance. Your 40 seconds starts now.
T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. The solution would be, by using alternative solution to solve for the variance, we will add another column for y squared times p of y. So our solution will be for 6, we have 6 squared times 0.14, that is equal to 5.04. For 8, 8 squared times 0.52, that is equal to 33.28. And for 10, we have 10 squared times 0.34, that is equal to 34. And for the summation of y squared times p of y, we have 5.04 plus 33.28 plus 34, and that is equal to 72.32. To solve for the variance using alternative solution, our formula is variance is equal to summation of y squared times the probability of random variable y minus mean squared. That is 72.32 minus 8.4 squared, 72.32 minus 70.56. We have the value of variance as 1.76. Well done, grade 11 students. To wrap up the lesson we have today, you just need to comment a heart icon if the statement is true, and like icon if it is false. You have 5 seconds to react. Ready? Here's the first one. The first step in computing the mean of discrete probability distribution is to construct a probability distribution table. 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The correct icon is heart. Number 2. The sum of individual probabilities of discrete probability distribution can be greater than 1. 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The correct icon is like because the sum of individual probabilities of discrete probability distribution is exactly 1. Number 3. In computing the mean using alternative solution, there's no need to add another column in the given table. 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The correct icon is heart. We just need, or what we just need to do is to get the summation of x times the probability of random variable x. And last, we have to solve for the variance of a discrete random variable. The value of mean is not necessary. 5 seconds. Go.
5, 4, 3, 2, 1.
Time's up. The correct icon is like. The first step to solve for the variance actually needs the value of the mean. Okay, that ends our session for today. For your assignment, kindly answer assessment items A and B on page 10 of your Statistics and Probability Self-Learning module. For questions and clarifications, please make sure to attend your follow-up discussion with your mathematics teacher tomorrow. Thank you for listening and participating in our session today. Again, this has been Mr. Jherald Gabica, your Statistics and Probability live streaming teacher, leaving you with what Kirti Chowdhury once said, the variance of people depends on how mean they can be. So be good to others and treat them the way you want to be treated. Let's always have high hopes that better days are coming, and always remember to stay safe, stay at home, stay in love with your studies. Happy Valentine's Day. God bless us all.